Hello, my beautiful students. Hope you are all doing well, having a great time, and of course, staying safe. So, in this chapter, we will try to talk about motion and force. So, this is Science Lesson Class 4, and let's start. Before starting today's lesson, we will do the chapter review in page 254. So, the first question says, a pathway for current is called circuit. That's the answer. The second question says, space and space are similar because they are both areas where forces can act without object touching. Your answer should be electric field and magnetic field. The third question says, current pass easily through a blank, but it does not pass easily through an blank. So the first blank is conductor. So current pass easily through a conductor and cannot pass easily through an insulator. So the second answer should be an insulator. The fourth question says a core wrapped in a wire that carries current is called electromagnet. The next question says a measure of extra charge that are on an object is called charge. Then we have a material that resists the flow of current is called resistors. Resistors can actually resist the flow of current. Seventh is an space or blank is a flow of charge. Electric current is a flow of charge. Next question says in a blank, taking out one light does not turn off the whole circuit. In a parallel circuit, when you take out one of the lights, it does not cut the whole circuit. The next question is the charge that stays on an object is called static electricity. Question 10 says a blank attract object made of iron or steel. Magnet can attract object made of iron or steel. Question 11 is a blank has only one path for the current. The answer is series circuit. Question 12 says energy to move current through circuit is supplied by exactly electric cell. So electric cells provide energy for the circuit. Question 13. A blank is where a magnet's pull is strongest. Yes, you guessed it. A magnet pole is where a magnet's pull is strongest. Moving on to the check understanding. So it is basically a multiple choice. The first one says an object has a blank charge if it has extra positive charge. Your answer should be D, positive. Second question says if the electric field of two charged objects form a closed pattern of field line, the objects are, your answer should be D, oppositely charged. Third question says if one bulb is removed from a series circuit, the other bulb will go out. Exactly. So your answer should be D, it will go out. Question 4 says the strip of material that glow in a light bulb is, so your answer should be D, a resistor. The strip of material that glows in a light bulb is a resistor. In this lesson, we will try to talk about motion. In order to understand motion, we will have to talk about position. Everything in nature, everything in the world has a specific position. Now, how do you tell someone where is your location? Where are you exactly? Probably you will tell him, I'm near the door, behind the desk, under the tree, or you can say, I am 2 meters to the left of the car, for example. Each of these describes a certain place or position. Now, if you gave the person who is asking you about your location a good direction, he will probably can get into your location. So what is a position? A position is a definite place. A certain place is a position. Now we can actually talk about motion, because motion is any change of position. Motion is any change of position. Let's say you are sitting in the classroom in a certain position and your teacher asks you to move your position to another place, then you are in motion. So like we said, motion is any change of position. Any change of position is called motion. The picture in front of you shows a biker who is riding a bike, and the biker is in motion, as you can see. So how can we say that he is in motion? He is changing position. That's why we can say he is in motion. Let me ask you a question. Are you in motion? Are you moving? Probably you will say no. You don't sense any change in your position. How could you give me that answer? Well, you looked around. Probably you looked around, and by checking or referring to the things around you, you actually made that decision. Now, in this case, we will have to understand frame of reference. What is a frame of reference? It is things around you that you can sense and use to describe motion. So if I told you, give me your address, how can you tell me your address? Exactly. So to describe your position or your home, you need a frame of reference. On a map, you find position by looking at the landmark, streets, names of mosques, schools, anything around you that people can actually find. So once again, frame of reference is the things around you that you can sense and use to describe motion. Let's go back to the first question that I asked you. Are you moving? Let me tell you a few information, and you should decide to answer according to that. You know that Earth is rotating on its axis and revolving around the sun. So even when you are sitting on your desk at your home doing nothing, you are actually moving. But you cannot sense the movement. But if an astronaut is watching you from the space, very far away, his or her answer probably will be different, because the frame of reference is different. From the space, astronauts see Earth rotate. So from the space, the Earth is moving. So what is a relative motion? Relative motion is the motion that is described based on the frame of reference. So at your home, on your chair, while you're listening to me, your movement relative to your own room is nothing. But your movement relative to the astronaut in space is very, very fast. Let's say Muhammad is watching Yara and Ney riding their bikes on the street. For Muhammad, the frame of reference is what he sees by standing still on the sidewalk. Relative to him, the two girls are moving and the building and the street are not moving. What about Ney's frame of reference? Ney's frame of reference is what she sees on her bike. Relative to Ney, Yara is not moving because the two girls are riding at the same speed. To Yara, the building and street seems to speeding by. What is a speed? A speed is the measure of an object change in position during a unit of time. So, whenever an object change position during a unit of time, we call this speed. If I ask you what is the speed of that swimmer, the person who is swimming, in order to be able to answer this question, you need to know the distance and the time. Let's say that the swimmer is moving a distance of 1 meter during each second. So during 3 seconds, he or she will travel 3 meters. Now you'll have to know, in order to know the speed of this swimmer, often a stopwatch is used to measure the time during the track swimming event, and also in some track and swimming event, distance is measured in meters. You also have to know that we use speed for many things in our life. For example, many people says that my house is only 5 minutes away from the school. The person who hears this phrase probably will understand that your house is near your school or not very far away from your school. But if you said my house is only 5 minutes spaceship ride away from the school, then the person who will hear this will understand that your school is very, very far away from your home, because a spacecraft is very, very fast and it has a lot of speed. Let's talk about force. So there's a very simple question here we need to ask and answer. What is force? A force basically is a push and pull. Do we use force? Of course we use force every day for everything. Whenever you want to open a door, either you push it or you pull it. Or when you go with your mom and dad to the supermarket, you use the grocery cart. You either have to push it or pull it in order for the grocery cart to move. Whenever you use a pencil, you need to push the pencil across a paper, right? So you use force in every task, basically every task you do every day. A force is a push or pull. Or you can say the force is a transfer of energy. Look at the picture of the archer that you are seeing in front of you. Actually, it shows you how the archers pull on the bowstring. When he lets go, the string will push the arrow away from the bow and toward the target. So now you realize that the archer is actually using force. He pulled the bowstring, then he pushed the arrow. What about when you throw a ball? The force of your muscle move your arm to push the ball into the air. So you are using a force. When you pick up a book, the force of your muscle moves your arm to pull the book off the desk or from the ground. Now, if you look around you, you will see many different kind of force, other force that are pushing and pulling things all around you. The force put out by car engine turns the wheel and pushes the car down the road. The force of a magnet pulls a metal towards it. So now you understand force. The push or pull is all around us. If I told you look around you, you will see a lot of things in your own room, in your own house, and you will realize that things around you probably are motionless or they don't move. The book on your desk is not moving, it is motionless. The picture on the wall, it is not moving, it's motionless. The door is not moving. Of course, unless you push it or pull it, then the door will start to move. So objects stay in the place unless a force starts moving them. If something is moving, you'll probably have to know that there is a force acting on that thing. How a force affects an object depends on object's mass. To understand this part, I need you to look at the figure in front of you. Look at figure A. Figure A doesn't contain any load, so it is empty. Figure B, on the other hand, contains 12 kilograms of load. Which one do you think it will be easier for you to push or pull? Of course, the wagon in the figure A, because it doesn't contain any load, while the wagon in the figure B, since it contains 12 kilos, you need a lot of force in order to accelerate it, or you need to apply a full force. So remember, because the wagon in figure A doesn't contain any load, you can actually push it much easier and it will go much faster. It will move much faster. While the wagon in figure B, since it contains a lot of load, which is mass, you need a lot of force in order to push it. So let's make a rule out of this. A force affects an object with less mass more than it affects an object with more mass. If an object has less mass, it will be affected more by a force. While if an object is very heavy, you need a lot of force in order to affect it. So what should I do if an object is moving? A cart is moving, a wagon is moving, and I need to stop it. What should I do? You need to affect it by a force. So once an object is moving, it moves until a force stops it. We have a special kind of force that actually do the stopping, the whole stopping things. Whenever an object is moving, we have a force that affects it and stops it. This force is called friction. Friction is a force that keeps objects that are touching each other, for example, the tires of the cart, the grocery cart, and the floor. These two objects are touching each other from sliding past each other easily. So remember, friction is the force that keeps objects that are touching each other from sliding past each other easily. Since you understand what is force, and you already know that force can actually start a motion or make an object move, starting is a change from no motion to some motion, right? But force can actually change motion in other ways. For example, you can speed up or slow down, turning and stopping. To be able to do this different kind of motion, you need a force. So whenever you are riding your bike on a smooth, level surface, you know that you don't need to do much pedaling because the road is smooth. So the bike will keep going for a while without you pedaling continuously. But once you want to go or you want to speed up, you have to pedal. So what happens is the following. The force of your feet pushing on the pedals speeds up the bike. To slow down or to stop, you squeeze or put force on the brakes. Of course, you can change direction whenever you want to, right or left, by turning the handlebars to right or left. Why I am explaining all that? I'm pretty sure most of you know how to ride a bike. But what I'm interested in is how you can stop, start, or slow down and change direction to left or right whenever you want. Starting and slowing to stop are example of changing speed. Turning is an example of changing direction. Also, both changing speed or changing direction is actually called acceleration. Acceleration is any change in speed or direction of an object in motion. Imagine we have an object in motion, or you could be in motion with your bike, and you are changing its speeds. You stop, then you start to move again. You change direction to left or right. You are actually accelerating. Remember, acceleration is any change in speed or direction of an object's motion. There is very, very important thing to know. It always takes a force to cause acceleration. Without a force, acceleration could not happen. Adding force. Look at the image in front of you. You will see two hands pushing a box, opposite direction, but same amount of force is applied on the box. The box is not moving to any direction. Why? Because the forces are balanced. When all forces acting on an object are balanced, the motion of an object does not change. It does not accelerate. Now, if one of these hands try to push harder, the box will move toward your friend. So what happens when the forces are not balanced? When forces of an object are in opposite direction, you subtract the smaller force from the larger force. The force that remains will accelerate the object. And of course, the direction of the movement will be the direction of the larger force. You can see the picture of balance versus unbalanced force. The first one, we have two groups of people that they apply the same amount of force, 300 Newton. The second image is two groups. These groups, they apply different amount of force. The first group applied 300 newtons. The second group applied 400 newton. So subtract the small force from the large force. The force that remains will accelerate the object to a left, because the larger force was from the left. It was the 400 newton. Measuring force. Well, first, how do we measure force? And which kind of tools we use to measure force? We can use spring scale to observe the effect of force on an object, any kind of object. The picture in front of you shows you a spring scale. Now, the number on this spring scale shows you the size of force in the unit of Newton. So Newton is the metric or System International SI unit of force. So whenever you want to write Newton, we use N, and you should use it too. This is the short way to write Newton, capital N is used. And also there's another thing. Spring scale is used to measure weight. So here I'll have to ask you another question. Do you know what is weight? Weight is the measure of force of gravity between Earth and the object, any kind of object. For example, the weight of that human in front of you is the measure of the force of gravity on that human, or between Earth and that human. Of course, we reached the end of this book. So we finish science for this year. My best wishes to all of you. Have a great time and a great holiday, and good luck. And this is your final homework, the chapter review in page 272, 273. Do your best and enjoy your time. Stay safe and good luck.